This is our second video on the normal distribution. And on this one we start to use the calculator and we start to understand this the symbolic meaning. So on this one, when they give us something like this, what they're telling us is that our data is distributed normally. So it's going to follow that normal curve, and I'm going to draw it in a second, with a mean. The first number here is the mean, and then this value that gets squared is the standard deviation. To be honest with you, I don't know enough stats to know why that's why they write it as the standard deviation squared, but that's just how it works out. So that's what the statisticians decided to do. Okay, so we're going to take this. We can draw our curve, roughly look something like this, and we know that our mean is at, they told us our mean was 10. And so one standard deviation is 2.3. So a standard deviation away is going to be about at 7.7, and then over here at 12.3 would be one standard deviation. But they're saying, now sketch this, that we want to know what's the probability that it's between 8 and 11. So roughly something like that. Well, now 7.7 is one standard deviation on that side, and then 12.3. So if you remember from the last video, 68% of our data is within one standard deviation. This is going to be less than that because we're not going all the way out to 12.3. We're not going all the way out to 7.7. But we're trying to figure out what's the probability that if we select a random piece of data that it falls within this range. Okay, and so I'm going to show the CASIO. Let me clear this so you can see. Starting fresh, if I okay, so I've reset the memory. So I'm going to come in here, menu, I'm going to go to statistics. Now what I'm looking at is I'm looking at a distribution. So I'm going to hit this F5 to get to distribution. We're talking about a normal distribution, and we're looking at this cumulative distribution here. So our data does not come from our list, our data, so we hit this variable. And now they want to know, okay, what's the lower bound of the interval that we're looking at? Well, it's 8. What's the upper bound? It happens to be 11. And then the next part is the sigma, which is the standard deviation. So that's the 2.3. Mu is the mean, and that's 10. And now we hit enter. And what this is telling us is it's telling us the probability that you're in this interval here is 0.475. And keep in mind, IB likes 3 sig figs. So we'll say here at the bottom of the problem, we'll say that the probability that our value lies between 8 and 11 is about 0.476, or 47.6%. Okay, the next thing that they might ask us to do is, okay, so what's the probability that it's less than 12? Well, so if it's less than 12, pretend I can draw, that's 10. So here is 12. If you think about it, on this one, remember how we said that if it had been within one standard deviation, it would be 68%? Notice this is less than that, which is what we expected. So it's always a good idea to kind of think in terms of what would be a reasonable answer for this problem. So here, we want to know what's the probability that it's less than 12. So I'm wanting to know what's the probability that it lies in this region. Well, if you think about it, 12.3 is kind of right in here. That was one standard deviation. And so, I'm going to ignore that phone. I will call Ms. Deloach later. This 68% was within one standard deviation. This is 38 plus 50, so that's 84%. So about 16%-ish is greater than this. So that gives us an idea of what's a reasonable answer. I'm sorry about the phone call. I want to keep going with your video. On this, we're going to come back on our lower bound. We don't know if it stops at 0. So we're going to say -1 times 10 to the 99. That is as big a negative number as we want to deal with. The upper bound here is 12, and then everything else is still valid. So we end up getting 80, well, around 3 sig figs. That's 0.808, or 80.8%. The next one we're looking at is the probability that it's greater than 9. Well, this is 10, so we're looking at something like this. Here's 9. I expect something bigger than 50%, but not a lot bigger. So I'm going to come back to my calculator. I want to start at 9, and I want to go as big as I need to. That is as big as I could possibly want. And like I said, it's bigger than 50%, it's about 66.8%, if you want to write it as a percent. Okay, and then I think on the next one, okay, we'll keep going. We'll do it all in one video. I was hesitating on that. On this next one, what we do here is we come back to our distribution. We're a normal distribution, but we're trying to figure out, they've told us our mean and our standard deviation, and then they've now said, well, what value gives us, hang on, let me draw this curve. Okay, if this is normally distributed, there's our mean. They want to know less than what value is about 95%. So they're saying, well, what's this of k value out here where 95% of the data is less than that? Okay, so on that one, when we come to our calculator, we're going to do that inverse. And we want to know, let me make sure I don't say this to you incorrectly. Sorry. We want to know, our tail, notice, is to the left. And then we have, we want to know what the area is. We want 95%, so that 0.95. We have now changed our standard deviation. We've now changed our mean. And here we go. Our new value, the value of k, would be about 28.7. So they're telling us that whatever this data is, that 95% of the data is less than 28.7. If we have something like this, I hope you're noticing how drawing the curve and shading it gives us a real good sense of what we need to plug into the calculator. I'd strongly encourage that. And the last one, they're saying what value of k is going to make it so that x greater than or equal to k is 0.6. Well, this is 50% over here, so we're going to come somewhere in this spot. So we want all of this to be 0.6. So this was 23.6. We're going to try and find that number. It should be less than 23.6 for sure. We'll come back out. This time we want our tail to go to the right. We want the area to be 0.6, and everything else stays the same. And so this becomes, that k value is about 22.8.